In this video, we'll look at the kinetic molecular theory of matter. The kinetic molecular theory of matter states that matter is made up of a large number of atoms or molecules that are in constant motion. If we consider a gas, there's a large amount of energy in the particles, so they're in constant motion. There's also a large space between the particles, atoms or molecules. And because of this large space, there's little to no interaction, attractive interaction between the atoms or molecules. If we consider a liquid, in a liquid, the amount of energy in the particles, the kinetic energy, is less, so the particles are moving at a slower rate. They can slip past each other, but unlike the constant random movement that we see in gases, the movement is going to be considerably less. There's also a smaller distance between the particles than in a gas, but greater than what we'd expect in a solid. This smaller distance between the particles, the atoms and molecules, allows for stronger attractive forces between the particles. This will limit the volume. Often we consider that the volume of liquids is constant under normal temperatures and pressures. If we look at a solid, the energy is very low. The particles are barely moving. We can consider that they're vibrating around a fixed point. They're also tightly packed. Most solids are crystalline, meaning that they are so tightly packed that they adhere to the smallest possible distance between the particles. Because they are so tightly packed, the attractive forces between the atoms and molecules is very strong. This gives solids fixed volumes and shape. One of the other things we can use the kinetic molecular theory for is to explain phase changes. How we go from the phase of solid to liquid to gas. If we think about going from a solid to a liquid, as we increase the temperature, we're increasing the energy in the atoms and molecules. This increase in energy is increasing the kinetic energy of the particles, and they begin to increase in speed. As they start to move, vibrate faster, there'll be a point when they overcome the energy that is keeping the particles attracted to each other. If we think of a liquid to a gas, again, increasing the temperature increases the kinetic energy. The increase in kinetic energy to the point where the attractive forces between the molecules is overcome by the energy of the movement of the particles, there we go from a liquid to a gas. As you can see, if we think about solids, liquids, and gases as particles in motion, we can see how increasing the temperature, which is increasing the kinetic energy, can go from one transition to another.